Hello, this is Prakasham. Today I will discuss about stability analysis in S-domain concept. So what is stability analysis and what is unstable systems? The term stability refers to the stable working condition of a control system. Every working system is designed to be stable. In a stable system, the response or output is predictable or finite and stable for a given input. So, what is stability analysis? Every system for a small amount of time has to pass through a transient period whether the system will reach its steady state after passing through the transient or not. The answer to this question is whether the system is stable or unstable. This is this is the concept of stability analysis of a control system. So for example, the example of the stability analysis of a control system, for example, we want to reach, we want to go from one station to other station. The station we want to reach is our final steady state. The traveling period is the transient period. Now, anything may happen during the traveling period due to the bad weather, road accident, etc. There is a chance that we may not reach the next station in time, correct time. The analysis of whether the given system can reach steady state after passing through the transients successfully is called as stability analysis of the control system. So what is a stable? Every bounded input produces a bounded output. Otherwise, every bounded input produces a bounded output is called as a stable system. Otherwise, this system is said to be unstable system. Next, types of stability. The stability can be classified as three types: absolutely stable system, conditionally stable system, marginally stable system. So, what is absolutely stable system? If a system output is stable for all variations of its parameter, then such a system is called as absolutely stable system. And the second one is conditionally stable system. If a system output is stable for a limited range of variations of its parameters, then it is called as conditionally stable system. And third one is marginally stable system. So what is a marginally stable system? For a bounded input signal, if the output has constant amplitude oscillations, then the system may be stable or unstable under some limited constraints. Such a system is called as limitedly stable system or marginally stable system, and the graphical representations as shown in figure: stable system, unstable system, marginally stable system. And the next explain, and this is the explain x real axis s is equal sigma plus j omega, real part of s and imaginary part of s. X axis is the real part of s sigma and y axis is the imaginary part of s j omega. The left half of the s plane is called as stable system and the right half of the s plane is called as unstable system, and the poles are located on the imaginary axis, then it is called as the marginally stable system. Next, discuss about Routh-Hurwitz criterion. So, what is Routh-Hurwitz criterion? The necessary and sufficient condition for stability is that all of the elements in the first column of the router. The necessary and sufficient condition for stability is that all of the elements in the first column of the router be positive. Otherwise mean if this condition is not met, the system is unstable and the number of sign changes in the elements of the first column of the row array corresponds to the number of roots of characteristic equation in the right half of S plane. How to construct the router? How to construct the router? For example, consider the characteristic polynomial. The characteristic polynomial equation is a naught s power n plus a1 s power n minus 1 plus a2 s power n minus 2 plus and so on an s power 0. And this is the characteristic polynomial equation. So in this characteristic polynomial equation, the coefficients of the polynomials are arranged in the form of two rows. So the two rows are, and the first row is s power n row and second row is s power n minus 1 row. So what are the coefficients of s power n row and s power n minus 1 row? The coefficients of s power n row is a0, a1, a2, a4, a6, a8 like that. And the coefficients of s power n minus 1 row a1, a3, a5, a7, a9 like that. So now here from these two rows, first row is s power n row. When n is even, then s power n row is formed by the coefficients of even order terms and s power n minus 1 row is formed by the coefficients of odd order terms. And similarly, if n is odd number, then s power n row is formed by the coefficients of odd order terms and s power n minus 1 row is formed by the coefficients of even order terms. So that is s power n row and s power n minus 1 row arrangement from the given characteristic equation from the given characteristic polynomial. How to find out the remaining rows up to s power 0 rows? The other row, each row of the row array is constructed by using the previous two rows elements. So what are the remaining rows up to find out s power 0 s power 0 row? S power n minus 1 2 row, s power n minus 3 row and shown up to s power 0 row. And the next row is s power n minus 2 row. So for example, s power n minus 2 row coefficients are b1, b2, b3, b4 like that. How to find out that coefficient using previous two rows elements? And the coefficient b1 is equal a1 a2 minus a0 a3 by a1. And similarly, the coefficient b2 is equal a1 a4 minus a0 a5 by a1. And b3 coefficient is a1 a6 minus a0 a7 by a1. So these are the coefficients of s power n minus 2 row. Similarly, find out next row, that is s power n minus 3 row coefficients c1, c2, c3 values. Similarly, using previous two rows. What are the previous two rows? S power n minus 1 row and s power n minus 2 row. C1 is equal b1 a3 minus a1 b2 by b1 and quotient C2 is b1 a5 minus a1 b3 by b1. So similarly find out the coefficients up to s power 0 row. The elements b0, b1, b2, b3 are computed until an element equals to 0. You can find out the elements b1, b2, b3 and so on until an element equals to 0. In the construction of row array, the missing terms are considered as zeros. The missing terms are considered as zeros. So the construction of row array can be classified into three types. So that is First one is normal row array. Second one is a row of all zeros. And third method is first element of a row is 0. Normal row array. Second one is a row of all zeros. And third one is first element of a row is 0. And the first method of the row array construction, normal row array. So what is the procedure? How to estimate, how to find out the stability and instability of the system using this method, that is normal row array method. In this case, there is no difficulty in forming row array. The sign changes are noted to find the number of roots lying on right half of S plane, and the stability of the system can be estimated. In this case, if there is no sign change in the first column of row array, then all the roots are lying on left half of S plane and the system is stable system. If there is any sign change in the first column of the row array, then the system is unstable system and the number of roots lying on right half of S plane is equal to the number of sign changes in the first column of row array and the remaining roots are lying on left half of S plane. The remaining roots are lying on left half of S plane. So for example, in this case, in this method, for example, consider one example. Using Routh criterion, determine the stability of the system represented by the characteristic equation s power 4 plus 8s cube plus 18s square plus 16s plus 5 equal to 0. Comment on the location of the roots of the characteristic equation. So what is the given characteristic equation? This is the given characteristic equation. The given characteristic equation is which order characteristic equation? Fourth order characteristic equation. So it has 4 roots. So what is the maximum power of S? Given characteristic equation, maximum power of S 4. So therefore the given characteristic equation can be arranged in the form of 2 rows. So what are the 2 rows? And the first row is S power 4 row and the second row is S power 3 row. So what are the coefficients of S power 4 row? 1, 18, 5. So what are the coefficients of S power 3 row? 8 and 16. And S power 3 row is divisible by 8. 8 ones and 8 twos for the simplification purpose, for the construction simplification purpose. Find out the remaining rows up to S power 0 rows. Up to S power 0 row. First find out the S square row. How to find out S square row elements using previous 2 rows elements. And the first element of the S square row is 1 into 18 minus 1 into 2 by 1. That is what is the resultant value? 16. And second element of the row array is second element of this square row 1 into 5 minus 1 into 0 by 1. So now here the 0 and the previous row S power 3 row, first element is 1, second element is 2 and third element. So now here that element is missing, the term is missing. That missing term is considered as 0. So that is the 0 value. So that resultant value of the second element of the S square row is 5. Next find out S power 1 row using previous 2 rows, that is S square row and S power 3 row. That element is 1.7. Next find out S power 0 row, that value is 5. Now here the first column element of the row array. So what are the first column elements of the row array? 1, 1, 16, 1.75. So these are the first column element of the row array. Here all the elements of first column of row array be positive and there is no sign change. There is no sign change in the first column of the row array as the system is stable system and all the roots are lying on left half of the S plane. So now here how many roots are there? There are 4 roots. Why? The given characteristic equation is fourth order characteristic equation. So because of that, the 4 roots are lying on left half of S plane. So this is the procedure we can find out stable and unstable system of normal router. And the second method is a row of all zero. So what is this method? A row of all zeros. In the construction of row array, in the construction of row array, any one of the row is having all zeros. How to find out stability of the system and unstable system? And the first step is determine the auxiliary polynomial, and the second step is differentiate the auxiliary polynomial with respect to s to get dA of s by ds. Third step is the row of zeros is replaced with the coefficients of dA of s by ds. And the fourth step is continue the construction of the row array in the normal manner. And the array is interpreted as two cases, two types. And the first one is if there are sign changes in the first column of row array, then the system is unstable. Here, the number of roots lying on right half of S plane is equal to the number of sign changes in the first column of row array. The number of roots on imaginary axis can be estimated from the roots of auxiliary polynomial. The remaining roots are lying on left half of S plane. And the second is if there are no sign changes in the first column of row array, then the all zeros row indicates the existence of purely imaginary roots, and the system is limitedly stable system or marginally stable system. The roots of auxiliary equation lies on imaginary axis, and the remaining roots lies on the left half of the S plane. So this is the procedure we can find out stability and unstability of the system, a row of all zeros method. So for example, construct the row array and determine the stability of the system whose characteristic equation is as shown. Also determine the number of roots lying on right half of S plane, left half of S plane, and on imaginary axis. So what is the given characteristic equation? This is the given characteristic equation. The given characteristic equation is which order characteristic equation? Sixth order characteristic equation. So it has 6 roots. What is the maximum power of S? 6. The given characteristic equation can be arranged in the form of two rows. What are the two rows? S power 6 row and S power 5 row. So what are the coefficients of S power 6 row? 1, 8, 20, 16. So what are the coefficients of S power 5 row? 2, 12, 16. The given characteristic equation can be arranged in the form of two rows as shown. The elements of S power 5 row can be divided by 2. 2 ones, 2 6, 2 8s. So S power 5 row 1 6 8. Next find out S power 4 row up to S power 0 row. Find out the elements of the row array, construction of the row array up to S power 0 row. So first find out S power 4 row. How to find out S power 4 row elements using previous two rows? So what are that elements? First element of the S power row is 1 into 8 minus 1 into 6 by 1. That value is 1. And similarly next element and next element. Next find out S power 3 row. S power 3 row. Here all are zeros. S power 3 row elements all are zeros. And this is the second method, a row of all zeros. In the construction of row array, any one of the row is having all zeros. How to estimate, how to find out stability of the system. So that row of all zeros, first find out the auxiliary equation, auxiliary polynomial. How to find out auxiliary polynomial? Before row of S power 3 row. So what is the before row of S power 3 row? S power 4 row. So therefore, the auxiliary polynomial equation is S power 4 plus 6s square plus 8. And the second step is a row of all zeros. Differentiate auxiliary polynomial with respect to s, dA of s by ds. So that the differentiation is 4s cube plus 12s plus derivative of constant is 0. Next third step is the row of 0 is replaced. The row of zeros is replaced with the coefficients of dA of s by ds. So what are the coefficients of dA of s by ds? 4 and 12. So now here the 4 and 12. That row S power 3 row coefficients are 4 and 12. So that row is divided by 3. 4 ones and 4 3. So therefore the coefficients of S power 3 row is 1 and 3. That is replaced by in place of zeros 1 and 3. And continue the construction of the row array in the normal manner, in the usual manner. So up to find out the elements up to S power 0, up to S power 0 row. So now here the elements of first column of row array is observed that there is no sign change. The first column of row array there is no sign change. The roots with all zeros indicates the possibility of roots on imaginary axis, as the system is limitedly stable system. So next find out the auxiliary polynomial roots from auxiliary polynomial equation. So what is the auxiliary polynomial equation? The auxiliary polynomial equation is s power 4 6s square plus 8. So this is fourth order equation. First consider s square is equal to x. S square is equal to x. In the above equation, substitute s square is equal to x, and the given equation is x square plus 6x plus 8 equal to 0. So find out the roots in this equation using the expression of minus b plus or minus under root of b square minus 4ac by 2a. B value is 6, a value is 1, c value is 2, and the roots of x is minus 2 and minus 4. But s square is equal to x. S is equal plus or minus under root of x. What are the x values? Minus 2 and minus 4. So therefore s is equal plus or minus under root minus 2 and plus or minus under root minus 4. J square value is minus 1. Minus 1 is replaced by j square. So therefore s is equal plus or minus j root 2 and plus or minus j 2. So what are these values? There are 4 values. There are 4 values. So therefore 4 roots are lying on imaginary axis and the remaining 2 roots are lying on left half of S plane. So this is the procedure we can find out stability of the system, a row of all zeros method. A row of all zeros method. And the third method of Routh-Hurwitz criterion is first element of a row is 0. First element of a row is 0. So in the construction of Routh array, in any row, first element is having 0. How to find out stability of the system? So what is that procedure? While constructing Routh array, if a 0 is occurred or encountered as first element of a row, then all the elements of the next row will be infinity. To overcome this problem, what is the problem, all the elements of the next row will be infinity. That problem overcome. To overcome this problem, let's substitute, let epsilon is equal to 0. Epsilon is replaced by 0 and complete the construction of the route array in the usual manner. So what is that usual manner procedure? Usual procedure observed in previous two cases, method 1 and method 2. And finally epsilon is replaced by 0 and determine the values of the elements of the array, which are the functions of epsilon. So this is the procedure we can find out first element of a row is 0. For example, construct the route array and determine the stability of the system represented by the characteristic equation s power 5 plus s power 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Comment on the location of the roots of the characteristic equation. So what is the given characteristic equation? The given characteristic equation is the fifth order characteristic equation. So it has 5 rows. The given characteristic equation can be arranged in the form of 2 rows. That is s power 5 row and s power 4 row. So what are the coefficients of s power 5 row? 1, 2, 3. So what are the coefficients of s power 4 row? Odd ordered coefficients 1, 2, 5. S power 5 coefficients, even order coefficients, S power 4 coefficients, odd order coefficients. So next find out the S power 3 coefficients. S power 3 coefficients. So what are the how to find out S power 3 coefficients using previous two rows elements? Using previous two rows, S power 4 row and S power 5 row. 1 into 2 minus 2 into 1 by 1. 0 by 1, 0. And the first element is 0 and the second element is minus 2. So now here the first element of S power 3 row is 0. That 0 is replaced by epsilon and continue the construction of the route array normal manner. So as shown, continue the construction of the route array normal manner. And next epsilon is replaced by, after that epsilon is replaced by 0. Epsilon is replaced by 0 and the elements as shown. So now here the first column elements of the route array. Observe that there are two sign changes in the first column of route array, and plus infinity to minus infinity is considered as one sign change and minus 2 plus 5 is considered as another sign change. There are two sign changes in the first column of route array, hence the system is unstable system and two roots are lying on right half of S plane and the remaining roots are lying on left half of S plane. So this is the concept of Routh-Hurwitz stability criterion. Next, advantages of Routh-Hurwitz stability criterion. And the first advantage is the stability of the system can be calculated without solving the characteristic equation. And the second one is it has less calculation time. And third one is the range of value of k for the stability of the system can be determined. And fourth one is the number of roots in the right half of the S plane can be determined in the case of unstable conditions. So these are the advantages of Routh-Hurwitz stability criterion. And the next one is disadvantages of Routh-Hurwitz criterion. So what are the disadvantages? It is applicable only to linear systems. This is the main drawback of the Routh-Hurwitz stability criterion.